大家好，今天呢非常荣幸呢再次来到香港，为 Near 的 founder Ilya 做一个 opening，那今天呢会为大家分享Near 最近的一些发展的计划以及在 AI 上的一些动作。先简单的介绍一下我自己，我叫 Amos，是 Near 的早期创始团队成员之一，也是之前的 CMO 和这个亚太区负责人。那现在呢，除了在继续为 Near 的生态做贡献呢，也是 Mad Web VC 的创始人。我们是一个3000万美元规模的早期 crypto 风投，我们背后的投资人有红杉，有刚才分享过的那个 Dragonfly，还有 SNZ 等等。那也介绍一下 Near 的2位主要创始人。Ilya 呢是 Near 的这个 CEO。他呢在做 Near 之前呢，其实有非常深厚的这个 AI 背景。他曾经是 Google 的这个 Research 的 Machine Learning 的研发负责人。然后当年呢写过一篇 paper 叫 Attention is all you need。那这个 paper 呢，其实呢就是开创了现代 AI 的这样的一个开山作吧，然后包括整个 ChatGPT 都是基于这个 paper 来研发出来的，包括他最近呢也跟这个詹森黄在 NVIDIA 的这个大会做了一些关于 AI 和区块链之间的这个分享。同时呢，他也是 Google 之前的这个 AI framework TensorFlow 最大的这个贡献者。Near 的另一位创始人呢 ，Alex 呢，他也有非常深厚的这个技术和这个 AI 方面的这个背景。他曾经呢是 Microsoft 的一个研发主管，然后也做了这个 MemSQL 的第一个 engineer。那 MemSQL 呢，其实是世界上很多大公司，比如 Uber、比如高盛、比如三星等等背后用的这个分布式数据库。同时呢，他也获得过这个 ACM ICPC 2008年的这个全球金牌。简单的介绍一下 Near。Near 呢，从比较简单来说，高度来讲，它是一个公链。那具体呢，它有3个特点。首先呢，Near 有非常强的这个性能。它现在应该是世界上性能最强的公链。主要是通过这个 Nine-Shade Sharding 这个分片的技术来进行平行的处理。同时呢 ，Near 是现在世界上所有公链、所有区块链用户数最多的一条链。每天呢，现在是大概有200-300万，甚至多的时候500-600万的这个日活。比它下面的3条链就从第2到第4条链加起来的这个 DAU 都要多。同时呢 ，Near 现在也在这个主推 Chain Abstraction，就是链抽象的概念。链抽象的意思呢，就是说你只要用一个 Near 的账户，就可以同时控制你以太坊、控制比特币、控制 Solana、控制 XRP、控制 Dogecoin、控制所有的其他区块链上的这个账户，也不需要进行一些传统的这样通过桥的方式进行跨链的一些操作。同时呢 ，Near 呢，现在也是这个模块化区块链的领头羊。它现在主要做的就是这个 data availability 那包括有一些竞争者，包括还有像 TIA 就 Celestia 都是一些很火的项目。那如果你现在用 Near 来做 DA 的话，你是要比以太坊便宜大概8000倍。那最后呢，也介绍一下 Near 背后的一些支持者。包括这个 Pantera， 包括 Terra Global， 包括 Dragonfly、ACNZ 等等。那在中国这边呢，有百度风投包括韩国的 Hash，都是一些区块链这里非常知名的一些 VC。好的，那我对大家的这个简单的介绍呢，就到此为止那之后呢，就由这 Ilya 在线上呢，为大家进行一个关于 AI 和 Near 之间结合的一个分享。
Hello, everyone. I'm Ilya, co-founder of Near, and today we're going to talk about why AI needs Web3. So the origin story of Near is actually in AI. And before starting on the startup journey, I worked at Google Research, focusing on natural language understanding, as well as being one of the major contributors to TensorFlow framework, deep learning framework from Google. Now, with a group of colleagues, we have created the first model called Transformers that has led to major innovation that we see right now driving AI. And this is the T in GPT. I left Google to start Near as an AI startup. We were teaching machines to code. And one of our approaches was actually doing a lot of data labeling, having students to create data for us. And we faced the problem of paying them, given it was a global workforce, and some of them didn't even have bank accounts. We started digging into blockchain as a way to solve this and realized that there's nothing that matched our needs, which were scalable, low fee, and easy to use, easy to onboard new people. And this is when Near Protocol started. Now, for those who are not familiar, language models is not a new thing. This existed since 1950s, and it was a general statistical model that allowed to model language and use it in various applications. Now, for me, the really interesting innovation happened in 2013 when word embeddings were introduced. And this is the idea that we can go from a symbol like New York to a vector in the multidimensional space that now you can do math with. And this works really well with deep learning models that are just a lot of matrix multiplications and activation functions. Now, after 2013, this is where I joined Google in at the beginning of 14, the predominant model that was used in research was recurrent neural network, which has a very similar approach to how humans read one word at a time. Now, that has a massive limitations because if you want to read, multiple documents to answer a question, you will have a pretty large latency, which is not feasible for using in production on Google.com. And so transformers were really born from our own challenges with recurrent neural networks. And we're really about trying to leverage the parallelism in computation that existed in the modern hardware, and especially in GPUs, to pretty much consume the whole document and try to understand it at the same time without having this kind of one step at a time bottlenecked. Now, what this allows to do after we introduce a model for OpenAI team to really scale it and pre-train it on immensely large corpus. And this led to major innovations we see today with ChatGPT, Gemini, and other models. Now, we see a major innovations happening with AI, and this is accelerating, right? These models are able to do basic reasoning, they have common sense, and we see people continue pushing the envelope of what's possible with these models. And I think importantly, where before with any machine learning, data science, there was a person who was interpreting results, right? You would get a bunch of tables, some analysis, and there was a person, a data scientist, for example, a machine learning engineer, who was interpreting results and really integrating it into a product or providing business decisions. What's interesting now with language models, with large language models, is that they are able to communicate with people directly, and they're able to kind of interact with other applications and tools. And so now we have something that's kind of bypassing potentially a person in between to interpret it. Now, for those who are not familiar, when we talk about these models being trained on GPUs or used, this is not your gamer GPU or even mining GPU for crypto. This is a specialized, pretty much supercomputers. Usually you have 8 of the GPUs in one machine that have a massive kind of computational capacity. And then these machines are stacked in racks. And then these racks are pretty much deployed in data center. And you train reasonably large models now, for example, Grok, on something like 10,000 H100s for 3 months. And this is about, renting that will cost you $64 million. Now, even more importantly, beyond the compute itself is the connectivity. So one of the important parts here is that the A100s, especially H100s, are connected by 900 gigabyte per second connectivity. So for reference, your CPU to RAM connecting at 9 gigabyte per second. So this is actually faster to move data between 2 nodes, 2 GPUs in a rack in a data center than to actually move data from a GPU to CPU. And especially now we still saw this Blackwell, there's a promise of doubling that to 1800 gigabyte per second. So it's insane speed that this hardware connects. And what it allows to do really is not think about these devices as separate devices, because they, from a programmer perspective, feel like a single operation. Now, there's a lot of caveats around that when you're building systems at scale, but the idea is really that these are highly connected devices, and kind of normal connectivity on local networks is 100 megabyte per second, so somewhere 10,000 times slower than this. Now, because of this kind of requirement for training, what we see now is that we have a rise of closed AI models. And even if the model weights are open source, we still don't actually know what went into the model. And it's important because these models are really about learning bias from the data. The kind of joke is that models are really just weights and biases, and that's just how models are represented. Now, there's a number of teams that, beyond just engineers, that go and decide what goes into the model by modifying data set, deciding that some content should not be in data for whatever reason, and then after model is produced as well, post-processing it and changing system prompt to decide what actually this model will inference. And especially dangerous is that we don't actually know how exactly this model was produced, because there's a potential for example, auctioning tokens to highest bidder, pretty much running ads directly in the output of the model. And we see kind of as well a massive backlash and legal battles that are rolling out because of everything from usage of data to how these models produce results to pretty much the power that these companies have over distribution platforms as they are making them kind of on the background reading the content, and the model itself becomes the distribution platform. We have massive risks that coming from this. Obviously, the regulators are trying to keep this under control, figuring out how to limit access for bad actors, and in turn, actually making it harder for open models and decentralized approaches to exist. The open source doesn't have enough kind of financial motivation. So what leads to is companies who potentially start with open source, then limit open sourcing their models as they're trying to monetize to gain more capital to buy compute to train a bigger model. There is currently no way to have a clear kind of understanding when people are misled, right? And again, generative AI here is becoming a tool to manipulate people at scale. And the economics of big companies always leads to skewed incentive, right? After you have achieved your target market share, you are, to continue showing growth in revenue, you need to increase average revenue per user. And so you need to pretty much extract more value from users. This is all the case for open source AI, using Web3 as a tool to kind of incentivize it, to create opportunity for people, as well as to create enough resources, compute, and data in the open for people to actually build competitive models. Now, there's a whole stack of AI tools that needs to happen in Web3 for this to come together. I'll cover a few pieces of this on data infra and app side, but obviously there's a lot more, and tune in for more conversations at other talks. So one of the important pieces is that because these language models are able now to interact with society directly, they're able to pretty much manipulate and obviously create fake information across the whole broad spectrum. Now, I want to point out that the AI is not a problem here, because these types of things existed before, right? And I have a picture here of just photoshopped images. And the important part is we need to leverage cryptography and on-chain reputation to combat that. So it's not about that AI generated this or human generated this. It's about who published it, what is the provenance of this, and what are the comments from the community that are actually important, right? So community notes as well as cryptographic provenance. And ideally, this is available everywhere on the internet, integrated across everything. The other side is we now have agents, and we're calling everything an agent. But the reality is there's a pretty big diversity here of things, right? There can be tools or autonomous agents, and this can be centralized or decentralized. For example, ChatGPT is a centralized tool versus the Llama models are open source, and so they can be used centralized or decentralized. You can also have decentralized models just running on user devices without, having, for example, blockchain or anything like that. Because if you run model on your device, you have the guarantees that it is doing exactly what you expect. And there's a fully autonomous, decentralized, for example, AI governance that requires, verification and as it, for example, distributes money and makes important decisions. So I kind of provide agent types, so it's easier to kind of describe, for example, when people working on something. There's different types of specialization. So this is prompt, where for example, zero shot teaching the LLM to respond in a specific way. You can fine tune with specific data to add more knowledge to the model, or you can do retrieval augmentation to add kind of in-context information when user requests. The output also doesn't need to be just text. It can be a rich UI component, as well as it can be a direct action, right, actually doing something on blockchain. And autonomy-wise, it can be a tool that is doing what you want. It can be something that writes its own plan and executes on it. It can be a continuous job that you just specify a goal, or it can be a reinforcement learning optimization where you just specify a metric that you want and kind of set a criteria and boundaries, and you let the model continuously explore and find ways to grow that. And finally, infrastructure, you can have centralized infrastructure like OpenAI and Grok. You can have a local model, which is distributed, and you can have a decentralized inference with probability. Now, there's a really interesting use case where we move away from just programmable money to intelligent assets. And this is where the asset behavior is defined by natural language and potentially can interact with the real world or with interaction with other users. Now, this can use, for example, natural language oracle that reads news. It can be automatically optimizing strategies based on what's going on. The biggest caveat here is that current language models are not robust to adversarial behavior, and so it's really easy to convince them in various things. So there's a lot more here. I will not go into too much detail, but I want to just leave you with this idea that we have a kind of closed AI world on one side, and it will lead to more manipulation. And the sad part, the kind of regulatory decisions usually will lead to that because regulators will require more and more oversight and more KYC and more requirements. And so only big companies are able to satisfy that. And startups, especially startups that are trying to do open source, will not have resources to actually compete and will be dying and getting acquired by big companies. And we're starting to see that happening. Or we need an alternative world where we actually have open models. We have commitment and ability to execute this from pretty much kind of nonprofit and open source mindset side. And we use crypto economic incentives to create opportunity and resources that are required to have competitive open source AI models. And so obviously as Near, we strive to do that as well as, through the whole ecosystem, we're working to enable this. So yeah, as Near, we'll have more updates in kind of coming weeks. And yeah, follow me on Twitter and X and Near Social for more updates. Thank you.